Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some Vulns in the Galaxy App Store again, and some cloud bugs in Google Cloud Compute Engine and Azure Cognitive Search. So, up first, we'll get into a bypass of Amazon's CloudTrail logging, which I don't think we've really talked about on the podcast before. It's a bit of a uh, special service, but it's basically AWS's event logging service, which records API requests and other events on an AWS account, which is extremely useful for things like incident response and such in the threat intel sphere. So, yeah, it's a pretty interesting target in that respect. And Datadog Security Lab started looking at some of the undocumented APIs, particularly a service called IAM admin. So typically requests will go through IAM, but they noted that while most of the requests went through that IAM service, some of them went through IAM admin. Um, and not only was that a different endpoint, but it also used a slightly different request structure, where like the headers were a bit different. The ex Amazon target header was larger, and it used an identity management admin service as well. The method names were also a bit different. For example, where on the typical IAM endpoint you'd have list MFA devices, instead they had list MFA devices for multiple users. Because with the IAM admin API, you could query multiple users rather than doing all the requests individually. Kind of makes sense for like an admin functionality. And yeah, finally, after testing the service, they found that there were no events generated in CloudTrail. So you could basically use this undocumented API to send requests to AWS and get results back with zero logging to CloudTrail, which is pretty significant because that's its entire purpose. Um, so yeah, kind of like a side door type issue. After enumerating some of the methods and studying the JavaScript, they found some various API calls where you could do things like list access keys for users and such. So it could be used for like reconnaissance on a target. That's what they call out here. And they'd have no way of knowing due to bypassing the logging. So it's quite a simple issue at its core, but it has a bit of an interesting impact, especially in like cloud environments like this.
And I kind of want to call out that they weren't actually looking for this sort of issue. Like they were just looking to see, oh, is this documented? The actual reason why they ended up looking at CloudTrail and noticing this in the first place was because they came across this undocumented interface. And they're like, well, I mean, is it maybe just calling the normal IAM stuff or the normal service there? And that's why they end up turning up going, hey, let's make that call. Let's look at CloudTrail and see, does it generate like IAM, like normal service requests? And that's when they noticed that didn't. So I want to call that out just because, I mean, if you're already doing AWS, you've probably thought about that already. If not, it is just a way to kind of understand what's being called there too. Like Spectre mentioned the threat intelligence aspect, but you are doing the bounty hunting and stuff, it can help you see what's actually going on um, when you make some of these service calls. Or what some services are actually doing. That's just a way of, just something to keep in mind, I guess, as you're uh looking for issues, looking for any surface or whatever. You can kind of see where things are going there. In this case, they end up kind of servicing this separate bug, but yeah, still pretty interesting. And I appreciate the fact this is one of those bugs that, it doesn't fall into your classic like cross-site scripting or code command injection or something like that. It's just here's the functionality of the application. It has security considerations, and it gets violated by this not being logged whatsoever. Um, I don't think they got a bounty for this, and that uh, I believe that has more to do with AWS not really letting you publish your research if you take a bounty. And being a company, they probably don't really care about the bounties as much. They don't actually call that out in here, so that is some speculation on my side. So
I vaguely remember us talking about this and the fact that Amazon, like the reason we don't really cover any topics that hit Amazon is because they have more of a strict disclosure policy.
yeah, that's
So
my understanding. I haven't actually gone to confirm that, so I could be wrong. Don't take my word for it. That's how the AWS bounty program works. Nonetheless, I mean, uh, it is an issue that you probably could have gotten a bounty for, despite the fact that it is a little bit different. It is very much a violation of the purpose of the service itself and not just a classic attack. So I don't know. I like those bugs. I like seeing that sort of thing because I mean, even as like we find ways of say centralizing, dealing with different issues like SQL injection, like cross-site scripting, we end up where a lot more of the bugs are going to be these things relate to what is the application actually doing versus what it's intended to do and those violations that create bugs. Yeah, definitely something to keep in mind as you're searching. In this case, they did just kind of stumble upon it. I still like seeing it, and you have to be aware of the fact there is a security consideration when the application isn't quite working how it's supposed to. Granted, not all bugs are security bugs.
It's all about the scope. Yeah. All right.
Yeah, cool
So
finding.
for sure, yeah, it's a pretty cool bug, and like you said, something we don't always see. So up next, NCC Group has a post on multiple vulns they found in the Galaxy App Store. And the reason I said again earlier is because we just covered a bunch of issues in the Galaxy App Store not too long ago, like I want to say like 4 or 5 episodes ago, maybe. So yeah, two vulnerabilities this time and fairly quick ones at that. First bug was an access controls issue where the App Store had an exported activity called alley detail activity that would handle intents. And one of the two methods in that activity would be used depending on if the intent had a data property or not. In the case of not having one, it would pull some extra or some intent extras into a content object and use that to start up a task that would install an application with the option to do direct installs and open it after it's installed. So any other like application installed on a Samsung device could automatically install any app available in the Galaxy App Store without consent and also open it. So pretty funny impact on that one.
Yeah, and the
Um,
thing here is this seems to be like the intended functionality
yeah,
is to
exactly.
allow
It's
this. Like
it's abusing intended features.
there doesn't seem to be like there's no match of any sort of limitation on what applications can trigger this intent or can trigger the activity, sorry. There doesn't seem to be anything there. It's just you send it this sort of request. It's you're passing in app information another way basically, and it'll just install it. Like it honestly is just kind of crazy to me that nobody thought that maybe this shouldn't be an exposed activity. Like nobody at all had that thought.
Yeah, just something that's way too permissive.
Yeah, I mean this is legitimate. I mean, in fairness, you do already have to have a application installed in order to install other applications. So the risk of this is a little bit lower. Like you already need something malicious or something needs to be compromised and then can do this. That said, you're the app store. Cross app, you know, um attacks are something that should be considered. But that is a
Mhm.
mitigating factor in terms of exploiting this. This isn't like you can just visit a website and it can trigger the install. At least not in this case.
Yeah. And of course you would have to have like a target app in the app store that you'd want to install as an attacker. That said, the on the Android side of things, it's not like the iOS app store where it's like very heavily vetted and there's a very tight entitlement system. Generally it's not super hard to get malicious things on like Android app stores. So I'm not sure about Galaxy App Store specifically, but I don't imagine it's super hard to get things on considering permission issues like this.
Yeah,
So
fair shout though. I actually I was kind of in my head thinking about the Play Store and the fact that you can get things on there pretty easily, but yeah, I'm not sure for the actual Galaxy App Store what would be on there. Um like how filtered down it is. I believe though it is still a generic Play Store and generally has access to what's out there anyhow. Like I don't think
yeah,
their offering is like some really special restrictive area.
yeah. So the second vulnerability they get into was a configuration type issue in the filter on the web view in the App Store. Typically, they want it set in such a way that the domain on the web view is limited to only allow listed domains over HTTPS. So on the cloud game deep links, they do some checks on the domain. Problem is, those checks are pretty flimsy. They're similar to ones we've seen in the past. First, the sender of the intent should only come from Samsung apps. And then the other check they do is on the monitoring host parameter. It should contain player.glb.samsunggamelauncher.com. The problem is both of these things can be faked by an attacker pretty easily. The intent sender can be set via the referrer name intent extra, and the monitoring host parameter check can be bypassed by just having that player GLB Samsung Game Launcher subdomain in your attacker domain. So, one of those classic issues of just checking if the whitelisted domain is, or like string is in your domain, as opposed to resolving directly to it. So
Yeah, I
something we've
mean,
seen before.
we've seen it a lot when it comes to like SSRF. That's one of the classic places you'll see this. They're trying to limit it to just that domain. They'll do their checks like it starts with this or host starts with, or as you said, includes this. So you can get around it through the use of subdomains. It's a fun trick. That said, this one, I don't know what the impact on this one actually is. So oftentimes when you have these web views, it's random application has, it launches a web view. Usually it's going to add something, in the JavaScript window that can then kind of call out or communicate with the host application and potentially the host device. They don't actually talk about any of that being present here. So, I mean, worst case scenario, if there's nothing there, it's literally just opening the window. You're getting some JavaScript execution. You can maybe do something with that one, but without having any clear impact, I'm not actually sure what they'd manage to do with this. Like, we have seen other cases where I think there was another app store where the window could be open. I don't think it was Galaxy, by the way, but where the window would be open, they could actually install applications through the web view. I don't recall what episode we covered that on, but I do recall that sort of issue, like as a potential vector of abuse. But without that, and when they don't mention it, it does make me think that they don't actually have much besides JavaScript execution here. So I'm not sure what an attack would be. And I'd be curious if anybody who's doing a bit more of bounty work on this side, if they're familiar enough to know like how damaging this would be having this cloud game access to. It sounds like something that might offer some sort of API, some sort of access, but again, they don't call it out, so I don't actually know what the potential damage here is.
It's also worth noting that referrer name intent extra can't be set from the Samsung browser, but it can be launched from Chrome. So there's a little bit of nuance there as well. But yeah, I mean, some pretty simple bugs in Galaxy App Store. Referring back to what we were saying earlier with where we're not super familiar with it, I'm not sure what like Samsung's obsession is with launching like, their own browser, their own app store, and all these things. I never really cared for it. I've owned a Samsung device in the past, and I just like didn't use it, uninstalled it. You know, I don't know what the obsession is, but
To
it
keep
does
you in
open
their
up a new vector of
ecosystem.
vulnerabilities.
One
Yeah,
of
it's like
one
they're
of
trying to Applefy Android almost.
well, one of the big things I think for the OEMs in terms of having their own browser, especially, is the search. When they're able to direct people into using Google search or whatever, I believe Google will pay some of the browsers to actually do that. That's how Firefox is making some of its money, or I think still does actually, through who the default search is there. So that could just be another thing Samsung's then able to sell, make a bit of a profit off of that. So I can imagine at least they're having some degree of control over the user base means they can then sell the users um as the product for something.
Yeah, fair enough. But yeah, whenever you have like vendors putting in all these, proprietary or modified applications, it's a good place to look for some of those vendor specific bugs. So, and yeah, the Galaxy App Store has been proving over our podcast the last couple episodes that there's some soft bugs in there.
I mean, Samsung on a whole, because we've talked about like Knox on the binary side too. Like they do a lot of customization, and
Yeah.
even stuff that is secure, like intended to be a security feature that ends up being a security weakness. They do a lot more customization, I think, than a lot of the other manufacturers.
Yeah. All right, so our next post is a post on an SSH key injection in Google Cloud Compute Engine.
Which is
Specifically, it's
not.
SSH in browser. Yep, go ahead.
I was just going to say that is not a Vuln class I hear very often. SSH key
No,
injection.
That's an interesting one. Yeah, I really like this post and like the nature of this bug.
Yeah, it's
So
simple, but it's an accurate title for sure.
yeah, so this is through this SSH in browser feature they have, which as the name suggests, it allows you to use like an SSH shell in the browser. And one of the things it allows you to do is change your username. Um, so, or your Linux username specifically. So on the back end, this would result in a GET request being sent with a parameter for the new Linux username to their API endpoint. And somewhat crucially, this request was sent with no like anti-CSRF protection or anything like that. But what was also weird was after playing with some of the requests and looking in the SSH key list, they noticed that some of their payloads ended up in the like SSH key side of things. And what they figured out was that this endpoint was used to update both the username and SSH key. And any content that came after a colon would be interpreted as the SSH key. So, summarizing this pretty simple attack, you could craft a malicious link that would add your SSH key to a cloud instance as an attacker, and then fish a victim into clicking it to add your key. Because there's just they just take the username and the key separated by the colon and and use it to add entries into the
So,
list. So
as this is a cross-site scripting, or not, sorry, not cross-site scripting, cross-site request forgery sort of attack, you don't necessarily need the victim to click the link that does this. You can just load this up, say on a form, add an image that causes that GET request to happen.
true,
Uh,
you just need to get them to go there. Yeah.
yeah, there are other ways of getting it that are a bit more practical than just phishing. It's really you just need to land on a page with an image controlled by an attacker, like any content really, or minimal content controlled by an attacker. Um, that is also a bit of a restriction, I think. They don't talk about this, so again, I have a bit of speculation on it, but you do need to know things like the project name, the instance zone, and the instance. You need to know that in order to get something at it. That can be a big ask. Like it feels like the sort of thing, an insider might be able to abuse, but just like a random outsider may not know all this information. The other thing is you probably need to be logged in at the same time. Like I can't imagine the session is lasting very long for you to just like randomly send this out when you visit. There are those sorts of restrictions going on here that they don't really talk about because the vulnerability itself doesn't really depend on it. Um, And they're just kind of general requirements for CSRF. They need to have an active session when you actually perform the attack. But this does feel like one of those cases that um, might be a little bit more limited because you're probably not just always logged in to the ssh.cloud .google.com and like any instance there.
Yeah.
But on a whole, like really fun bug. Fact that they're doing this over Get is actually kind of surprising. But it does sound like they either this was like an acquisition or they're using something else. I think they talk about it early on that this looks like I guess they just say but it feels like the sort of thing that maybe if they were designing this they wouldn't have had it, but something legacy kind of and they have the feature implemented that way. I don't know, it feels like a weird feature, honestly, even to implement it. Um Out of chat, Rudimal has the question. I wonder why XSS isn't just called JavaScript injection. Honestly, I feel like there's a bit of history on that one, even being why do you call it cross-site scripting when usually it's like reflecting on that same site? And I think that has a little bit more of just tradition where it's like, including the script tag to some other sites, so the source is somewhere else. I don't really know the origin of cross-site scripting, but it's always felt a little bit off to me, honestly. And it is effectively JavaScript injection, at least when we have that sort of attack versus HTML injection, where you can't actually get the XSS out of it. I don't know, it's an
And
interesting
typically in
question.
those cases, it is explicitly called HTML injection, like to call that out. So
Yeah, I mean, it's called HTML injection now. I know for a time some people did kind of include it under cross-site scripting. Um, and IABR mentions and replacing the word cross with an X. That's some fire. Um, yeah, I mean, I feel like that's sort of a historic thing. Like, XSS was something that was around in the 90s, maybe 80s. Um, yeah, I'm not entirely sure on the origin, but yeah, it's an interesting question. I kind of agree though. Like it would be more clear, I think, if you called it JavaScript injection. There might be some more nuance to why it's cross-site scripting though, but JavaScript injection does feel a bit more clear and more in line with at least how we're naming things now. And that's completely unrelated to this topic, but I'm not sure if we have anything else to actually say on this topic.
Yeah, I was just gonna call out pretty cool bug, and it did receive a decent bounty too. They got a $5,000 bounty and a $1,000 bonus through Google VRP. So
Oh yeah,
yeah,
and
pretty nice
I'm
bounty.
not sure if you mentioned it, but the user and key added did have sudo privileges on that same instance.
I did miss that. Good Ed.
Yeah, so Gade, highly privileged account being added there. And you might be thinking, if you have this functionality, why do you even need that injection? At least the thought kind of crossed my mind. It is kind of obvious why, but if you're attacking this as an attacker, as a remote attacker, you don't have access to what the key it generates is. Because normally these keys it's adding would be generated by the session rather than being like attacker controlled. So this also gives you the ability to add an attacker control thing. And Logical Poet added a link to the origin of cross-site scripting. So I am going to add that or open that up here just so it ends up in our show notes. Um, I have no idea how accurate this is, but being written back in 2006, seems like they might have some insight on it. Although interestingly, they do have cross-site scripting here as CSS. Uh, tying in with replacing it with the X, and forgot about that actually. With CSS also being the cascading style sheets.
All right, so we'll get into our last topic here, which is a cross-tenant network bypass in Azure. So kind of continuing on those cloud issues. Z, I'll let you take this one away.
Yeah, and this one is a uh kind of interesting issue and kind of just a really weird implementation choice. So what they have, first of all, Azure Cognitive Search, high level idea. You'll have your Azure Cognitive Search instance. It'll have access to data. It'll search that data. That is the functionality of it. It's just providing a nice search system. That is its service. It's just that access. So they added this functionality of allow access from portal, which is basically just saying like for all the data that's in this search instance, and the data is stored on the instance itself. It's not like it can pull in from elsewhere, I believe, but it gets stored there for actual searching. Allow access from the portal is basically saying like when you log in on the Azure portal, you can also see the data that's in the instance there and do whatever queries or whatever functionality it has. You would be able to do that from the Azure portal. And that is in spite of any sort of firewalling, any sort of restrictions that might exist. It'll bypass all of that and let you access specifically from the portal. So what they start looking into here is how is that implemented? Do they like whitelist the portal to access your instance? What are they doing? And is there maybe a vulnerability there? And what they found, ultimately, they go into a lot of kind of details about some things they found and some things they were looking into. Ultimately, what they found was that the portal was hitting effectively like a proxy service. That proxy service would take in an API key. So when you try and do something, it goes, makes this proxied request, has the XMS path query header there, which is hitting or specifying like what search index you actually want to request, sends it off. What's interesting is they expected this to do with the API key to take that token, make sure it's issued within the same tenant as the uh cognitive search instance is running, and to make sure that the token was issued for the appropriate security principal that the user has read permissions to access this, that, and kind of the usual things. What they found was none of that was happening. What they found was that the only thing Microsoft was validating here was that the token was still valid, just like not expired, and that it was issued for the Azure Resource Manager API, which like anybody can get for themselves. So basically, as long as a service was using this and allowed access through the portal, any tenant can take their API key and use that to access any other tenant, provided they know the instance ID and all of the information needed to actually craft valid URL. Just not checking any of the permissions of the API key to make sure they match. As it's good enough for us, so whatever, it's probably good. Basically letting you have cross-tenant access. Another kind of fun issue. Really weird to see it. Weird implementation choice, I think. Like especially just the lack of any sort of check on the API key, unless they were expecting the instance to then do the API key check and they like pass it along. Maybe they make sure it's good for their service and let the or pass the key along or something. They don't talk about that. We don't necessarily have insight on how it gets passed along or how it resolves that. Uh, but yeah, I guess honestly, a reminder that even on like the cloud APIs, that they very well may make these pretty fundamental mistakes in terms of just permission checking.
It's kind of funny because typically with these cloud issues, we've seen lacking permission checks, but usually it's on like a fine-grained level with like certain very specific actions, not like on a more global scope as this seems to be. So yeah, I mean that's a pretty interesting find, especially in something like Azure, where uh, it is generally like what you look to as setting an example a bit when it comes to cloud. It's pretty big in enterprise and stuff. So yeah,
Yeah, and that does remind me of some. They actually call out, I think at the top of this post, some of the other issues. Yeah, over the past 2 years, Azure has been confronted with a significant number of serious vulnerabilities, such as Azure Escape, Oh My God. I know we've covered Oh My God. I think we covered Azure Escape. I think they're both at the same time. Um, not super sure on that one. Either way, like there have been other ones there, but Azure, like one is their bug bounty. They do actually allow these things to be published, whereas AWS, we've had a handful of kind of serious bugs published, but I imagine they just patch a lot of them without telling anybody. Google's also pretty open though. Google's had some. Well, I mean, we're covering some other issues in Google this episode, but uh, they've had some issues, so it's not like Microsoft. I feel like they kind of make it seem like Microsoft or Azure is really insecure, and I don't think that's the case. I haven't compared the actual numbers, but I get the feeling that they've all had some kind of complex escapes and things that have existed in them. Um, at least Azure is letting this information get out there. Side note: the Oh My God one, if I remember it, was actually a kind of cool exploit chain. So do give that a read if you haven't already seen it. Um, and one thing I forgot to mention is this did get a $10,000 bounty. At least I think it was 10,000. Now I'm not seeing it in this page.
yeah, I saw it while you were talking earlier. It is 10,000 towards the bottom of the post, but yeah. So that's all of our topics for today. We had a bit of a cloud focus, but yeah, we don't see those topics all the time, so it was cool to cover some of them. Unless you have any last minute thoughts, see, we'll go ahead and wrap it up.
Yeah, no shoutouts this week.
All right, so thank you everyone who tuned in. VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. We also have some previous podcasts up on Spotify, Apple Podcasts, more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. And as always, we'll be back tomorrow for the binary episode. That'll be at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.